The universe contained precisely 5 times as much dark matter as baryonic matter. The locations of this dark matter are loosely correlated with those of the baryonic matter. The nature of dark matter is not any form of new or exotic particle, but instead is a form of gravitational ghosting. This ghosting is a result of space-time not being a simple Minkowski space as normally taken in physics, but instead a form of Grassmann space. The reasoning for this comes from my theory of the relativity of all matter, which I introduced in previous videos. The essence of this theory is that the universe is constructed out of absolutely nothing. That means no matter, no space, no time, no absolute information. So the basic entities from which it is constructed are abstract, whose only property is an individual identity. In effect, the physical universe is therefore taken to be an interpretation of the mathematical universe of integers. Because of the absence of any absolute information, it must contain all possible numbers of entities. The ordering of the successor function in arithmetic defines a primitive time for this abstract universe. Space is constructed by taking subsets of 3 entities at a time, the choice of 3 being to agree with physics, although it has some special benefits from a mathematical point of view as well. Because of the absence of absolute information, you cannot say precisely that any entity has a specific identity, and these identities are exchanged, and the exchanges of identities generate the symmetric group. If n is the number of entities at a given evolutionary time, then this group is the symmetric group on n objects. This leads to a form of uncertainty principle, like the Heisenberg principle, between a position coordinate given by an identity and a dual variable, a formal momentum defined as an eigenvalue of a single n cycle of the symmetric group. The sets of 3 entities define the points of a coset space of the symmetric group, namely symmetric group Sn modulo S3 times Sn minus 3. The operations of the symmetric group can be represented by permutation matrices. If we label a single entity by a letter I, then, and another one by the letter J, then a permutation of I with J can be represented by the matrix with the 1 at the points denoted Ij and Ji and zeros elsewhere. This leads to an alternative representation of this coset space in terms of coset spaces of the general linear group. In particular, this space, the coset space Sn modulo S3 times Sn minus 3, corresponds to the coset space of GLn on the n-dimensional linear group modulo GL3 times GLn minus 3 over the field of 2 numbers, Z2, i.e. the numbers 0 and 1, restricted to symmetric matrices. In physics, it's normal to say that the space-time is a continuum. In the case of this approach, it's reasonable to say that the continuum is actually a lower resolution approximation to the discrete space. Discrete space being GLn modulo GL3 times GLn minus 3 over the 2-component field Z2. So the continuous field associated with this in a natural way is obtained simply by replacing the discrete field Z2 by the continuous field R. So that leads to a very easy form of continuization of a discrete space. The Grassmann space has 3 times n minus 3 dimensions. Now in physics we normally treat space as three-dimensional, and it's actually quite feasible to treat this space as being three-dimensional because a discrete space is actually zero-dimensional, hence it can be embedded in a space of any higher dimension such as 3 times n minus 3. So we're simply using 3 coordinates rather than the full set of n to describe the space. The idea of Minkowski space then arises by taking these 3 spatial dimensions and adding another dimension corresponding to the evolutionary time n, and treating that as on a par with the 3 spatial dimensions. This entails an approximation by ignoring the evolutionary effects of an increasing value of n, which leads to extra points, extra particles, etc., which again I described in the earlier videos. This way of describing a space as being a 3 plus 1 dimensional space leads to certain anomalies, one of which is the existence of the dark matter, because a single point of the Grassmann space actually corresponds to 6 points in a supposedly three-dimensional space. And this is the basic cause of the dark matter. The next point to show is how the so-called dark matter actually creates a gravitational field. Now for this, we have to deduce the geometry of space from observations. These observations are carried out by means of photons. Well, the origin of photons in this theory comes from the gauge fields of the symmetric group. i.e., for example, the gauge field carried by a U1 phase group over a single exchange, which corresponds then roughly to a photon. Again, this is something which I described in the previous videos. So all our knowledge comes from these observations. Now, the way in which the geometry is determined is then from how the representations of these baryonic-like points is described. The uncertainty relationship between a position coordinate, i.e. an identity, and the formal momentum induces an element in the centre of the general linear groups. This comes from the Scherr theory of polynomial representations of the general linear group and the relationship to the representations of the symmetric group. So the n cycle of the symmetric group corresponds to a central element or diagonal element in the general linear group. And a choice of formal momentum introduces an implicit length scale into the general linear group, which breaks the invariance of the general linear group down to orthogonal group. And this leads to different values in general at different points in the space, so that the general geometry deduced from observations of these baryonic particles must therefore have an apparent curvature, which is essentially resulting from the uncertainty relationship that you cannot sort of define a sort of clear-cut length scale from momentum and at the same time describe the position. So this means that there is a gravitational type field which results from the energy momentum. Now at the different points associated with the baryonic particle and its 5 sort of images, will have a similar mass if mass is defined by the usual sort of E equals mc squared type of relation between the momentum and energy, mass. So that Each of these points will have, although it will have different momentum components, will actually have the same mass. So this gives a description of dark matter as causing gravitational fields. So I hope this clarifies the issue.